Hooke's law. Hooke's law deals with spring. Before starting Hooke's law, let's check what a deforming force and restoring force is. A deforming force is a force that changes the shape and size of an object, and restoring force is a force that helps to regain its original length and shape after the deforming forces are removed. So let's start with a spring with a mass attached to it. So the force or weight that is acting downwards will be equal to mass times gravity. So I can say that this is a deforming force. Which is acting downwards, and if the spring is in equilibrium, there is an equal and opposite force that is acting upwards. We can call it tension, which is same as the force that is acting downwards, which is equal to m mass times gravity. Now if the deforming force is not there, what is going to happen with this spring is that it is going to regain its original length and shape because of restoring force. Now let's start with Hooke's law. Hooke's law is a law that applies to spring. Let's start with a spring here with no load attached to it, and another spring with a load attached to it. So the difference in the length here is the difference in the length. We can call it extension, which is measured in meters, or I can call it delta L, which means the change in length, or H or E. I am using E here for convenience, which means extension. So we said that we double the force, we double the extension. That is what Hooke's law says. If we double the force, we should be double the extension too. So which means that force is directly proportional to E. To turn it to an equation with equal sign, we need a constant. So we can write this as F is equal to K times E, where K is the spring constant, K is the spring constant. The bigger K means it is harder to extend. For example, the spring of a car shock absorber, and a smaller K means it is very easy to extend, or I can say that it is a slingy spring. Now I can rearrange this equation to find K, which is spring constant. K equals F over E, and the unit for that will be Newton/meter. If we want to find the spring constant, I can plot the graph here. Graph with x-axis, force on y-axis, and extension on x-axis. So I can say force on y-axis and extension on x-axis. Now the graph is going to be a straight line if it is acting elastically. So it's going to be a straight line if it is acting elastically, or if it obeys, or I can say if it obeys Hooke's law. So if it is obeys Hooke's law, if the spring obeys Hooke's law, then the graph is going to be a straight line. Now I am going to find the gradient here. So this is delta H and delta Y. So gradient which is equal to delta y over delta h, which is equal to F over E, which is same as spring constant. So I can find the spring constant from the graph itself. The gradient of the graph will gives me spring constant. That's all. Thank you.